When we're talking about the oxidation of alcohols, remember, in the alcohol lesson, you have to know the classification of the alcohol. So let's begin drawing the three types of alcohols. I'm going to draw a primary alcohol, which is attached to a primary carbon. I'm going to draw a secondary alcohol, which is attached to a secondary carbon. And I'm going to draw a tertiary carbon, which is attached to a tertiary carbon. What are we going to use to oxidize? It depends what you ask your teacher, if he's only going to draw the arrow and write oxidation on top. But usually, mild oxidations occur with potassium dichromate. So this molecule is called potassium dichromate. Okay, 2Cr2O7. 2Cr2O7. Or this can also be called mild oxidation. Of what? Of alcohols. So, when we have a primary alcohol, such as this one, which is ethanol, and we add the potassium dichromate, let's ignore the potassium and the chromate. What's happening here is that we're changing the molecule completely, except for the amount of carbons. And what we're going to get is 2 carbon atoms, and we're going to get an aldehyde. So this oxygen, this hydroxy group, is going to be substituted by the carboxyl group, which is the double bond, and the oxygen. So a primary alcohol, when we're oxidizing it with potassium dichromate, is going to turn into an aldehyde. And if we look at it, this happens because the hydroxy group for the alcohol was on the edge of the molecule. Now, what happens when we do the same thing to a secondary alcohol? A secondary alcohol, the hydroxy group is found at the center of the chain. So let's think a little bit. If we oxidize a primary alcohol and it turns into an aldehyde, which is a carbonyl group, what is this going to turn into? Well, we're going to add the same carbonyl group, but substituting the OH. So we draw our same 3 carbons, we add a double bond and an O, and the oxidation of a secondary alcohol is going to turn into a ketone. In this case, remember, this aldehyde is called ethanol, ethane with the ol ending, and this ketone is going to be propanone. 3 carbons, propane, one, with the on ending making it a ketone. Now, what happens if we oxidize a tertiary alcohol? The natural thing that would come up in your brain should be that we do this, same shape, we add the double bond. However, we are in violation of the bonding properties of carbon, which can only establish 4 single bonds. Here it's making 5, so then this is not possible. Therefore, no reaction occurs. Whenever we encounter a tertiary alcohol that's being oxidized, we write no reaction because it would not react. It would not be possible. So if your teacher puts a trick question on the test, this would be a trick question. What happens if you oxidize a tertiary alcohol? And the answer is no reaction.